All right, why don't we get started? Thanks for coming. My name is Grant Ingersoll. I'm the CTO and co-founder of Lucidworks, longtime Lucene Solar committer. What I wanted to do today was present a project that my team has been working on at Lucidworks over kind of the summer. This was a variety of myself and interns and things like that. It's called SearchHub, and the reason why I said how to spend your summer keeping it real is because in my role as CTO, like I break it down into, I kind of do three different things. One, I visit a lot of customers. Two, I go to a lot of conferences like this. And then three, every now and then I get to write code. And so I'm not part of our core engineering team anymore. I'm more focused on kind of next generation things, machine learning, applications of search, of fusion, across our customers and kind of forward-thinking types of things like that. So this talk comes out of our need within my group to prove out some of these ideas. And so I'm going to start off with a little bit of a demo. I'll give you some pointers to why we're doing this kind of stuff. If you've ever used if you've ever built like an actual data platform, I think one of the challenges you always face as a platform builder, as an engineer, is that you don't really ever get to use your own software, right? Like you're building this platform that then helps other people do analytics and search and all of that kind of stuff, but you often don't apply it to your own thing. And so this SearchHub comes out of my need and the company's need to kind of do our own dog food. So I've got a whole dog theme throughout here. So hopefully you like dogs or puppies. I promised puppies in one of my tweets, so we'll have that. Anyways, if you want to follow along, all of this stuff is available. You need Fusion for it, and you need this code up at SearchHub. Otherwise, we can just run through a quick demo. How many people have ever been to the Lucene or Solar site before? Okay, so if you've ever then actually used this little tiny search box in the upper right corner, you know that there's basically two of us companies that provide functionality for that. We are the Lucidfind one, and so SearchHub is kind of our next generation version of this thing that we've called Lucidfind. And we primarily built this as a community service to help our own engineers as well as the community be able to search things like the Lucene website and the Lucene mailing lists and all of that kind of stuff. So this is kind of the genesis of this SearchHub project. I'll give you a little bit more details in here in a minute. As you'll see, it's expanded quite a bit from it. If I come and, good Lord willing, live demos, do something like search for garbage collection. I'm on the hotel Wi-Fi, so everybody else get off of that. You can see that it basically redirects to a Lucidworks branded site. If you selected the other provider, in all fairness, it would go to their branded site. And then, we've got things like our search results and all of our facets and all of that kind of stuff. And on the surface, a pretty vanilla, pretty straightforward search application. And that's somewhat the intent here too, because I want to show you over the course of this talk how we can then leverage various things both in this UI and in the underpinnings in Solar and Spark and Fusion to do some interesting things on top of this data. Okay, so very high level search interface. We've got lots of different data sources in here ranging from Solar itself through to Stack Overflow and on and on, okay? And so the goal for us, obviously, to provide a community service, but as well as demonstrate our capabilities. Okay, so that's kind of a quick and dirty, high-level context-setting demo. I'm not going to spend too much time on that just at the moment, other than now you know it's there and what it roughly looks like as I'm talking. And then what I want to do is kind of walk you through this summer experiment, if you will, of why we've done this. And then finish off with hopefully showing you some cool things about how when you combine Spark and Spark's machine learning capabilities with Solar, you can do some really fun and interesting things. Okay, so SearchHub at a high level, just kind of the meta of it. I showed you Lucene Solar integration. We actually have 37, I think at last count, different Apache projects. I believe there's 180 maybe 200 plus overall Apache Software Foundation projects. Some of them are up and coming, some of them are dying and being archived. We kind of try to focus on those ones that are in the realm of what we care about, as well as more popular projects. So there's things like Hadoop in here, and Spark, and Cassandra, and so on and so forth. Tinkerpop, which is one of the new graph ones, so on and so forth. As well as Lucidworks properties. All of our public data is in there, ranging from our public knowledge base articles, our videos, our website, etc. And then last but not least, Stack Overflow, which actually presented some really interesting crawling challenges, which I'll talk about here in a minute. I think all told right now we have 130-ish data sources, all pretty much continuously running and acquiring data via crawlers, via other connectors. It's running Fusion 2.4.2. Signals everywhere. I'll explain what I mean by that, but Signals essentially capturing feedback about what users are doing with the content. And then we ship this thing called Lucidworks View, which is kind of your out-of-the-box search UI. If you wanted to just take and have a search UI that you could show your boss or deploy internally within the enterprise, you can point and view at Fusion, and like a few clicks, a few configuration items, you have kind of the 10 blue links, facet search experience. More importantly, it's also open source and built on Angular. You can go and extend it if you want as well. I've seen customers very quickly deploy real search applications within their enterprise using Vue and Fusion. Last but not least, we actually are also mirroring a number of the ASF mail archives, frankly, because the ASF will ban you pretty quickly if you don't follow their rules around engaging with their content. And so this was our way of making sure we don't get banned by the ASF. So you have access to all of those email archives. As a company, a number of different goals that I mentioned. You know, at the company level, that Lucid Find thing obviously is a community service. It helps us engage with our customers as well as help you all get answers. We wanted to make sure that we had our own backend, our own software, running our own site. So obviously that's important. Like I said, when you're a data platform company, having a real production, living, breathing instance is a pretty important thing. And you want to make sure you can showcase all of your best features, not just, have those like kind of canned demos, but you want a real running live system. And then because the SearchHub project is actually open source as well, we can show you the code of how we went about building a Fusion application. And gee, if we didn't get it right, then how could we expect you to get it right? So we want to make sure it showcases best practices. So that's the company level view. My own view and my own side of it, I run a small team of essentially data engineers. We work with a lot of customers on showing them how to apply machine learning in a search experience. And so we have our own selfish view in our land. And that is, if anybody's done machine learning, you need data in order to do this kind of stuff. And as much as we love our customers and we get to work with a lot of their data sets, it's still their data sets, right? And so if we want a particular feature turned on in their application so that we can try out an experiment on our platform, well, maybe 6 months from now, I could convince them that that's a good thing and they'll go do it. So, but we want that final control, and so this gives us a site that actually gets a decent volume of user interaction and allows us to then run experiments, try out different search things, and then more importantly, actually share them back with you. It also then provides, my team, we often go out and do conferences and stuff like that. It gives us a means to demo and do, well, this kind of talk where I can actually show you things on this data set. So that's kind of the high-level goals. Digging in a little bit more, thought I would just talk through some of the different pieces around what this is actually made of, a little bit on deployment, and then we'll spend most of the time on kind of this notion of signals and machine learning and what this looks like at the code level, all right? And again, all the examples are up on GitHub, and you can have access to them there. So first off, I know, Trey and Will introduced it earlier this morning, Fusion. In a nutshell, I tend to think about Fusion as being built on top of 3 core principles. The first is this notion of next generation relevance, otherwise known as what Google and Amazon and the kind of the top level of search has already been doing for probably 5 to 10 years or more. But we want to try to make that stuff as accessible to you as possible. So when I think about next generation relevance, I think about it kind of as the 3 C's in my mind. The first is content. This is the stuff that Solr already does. You know, get all your content into Solr, make it searchable, create your phrase queries, etc. Do your tokenization, your language analysis, all of those kinds of things. Build out your auto-suggesters. It's all based off of, you know, that core content, right? And this is kind of the traditional search stuff that goes way back to, you know, the 60s and 70s around vector space models and all of that kind of stuff, right? And Solr is very, very good at that kind of stuff, right? The second one, though, and the third one is where I think it starts to get more interesting when you start to look at these next generation applications, is how do we start to capture the broader view of not just the data, but the user, right? I think oftentimes the reason why search applications fail is because they don't account for the user. And in fact, if you come to my keynote tomorrow, I've got a little rant in there built in on this subject, so please join me tomorrow afternoon. But the idea here around collaboration, right, is that, you know, we're constantly getting signals back from our users or our downstream systems about what matters in our data. So how do we make that easier for you all to capture and leverage in your search application? Because what we often see is that stuff's often locked up in marketing, or it's only, oh, hey, that's the business people that know that kind of stuff. Yet you as search engineers have built and generated all that data to begin with because you've built the search application, but yet you don't always know why or what's going on underneath the hood. You aren't necessarily thinking about user interactions, etc. So that's the collaboration aspect. You know, what are people clicking, tweeting, sharing, etc. And then last but not least, context. This is about who are you, where are you, what are you doing, what have you done in the past, what security roles do you have, are you an expert on this, are you a new user, etc., right? What can we leverage from the context of the situation to help make your search better, help you find that next best action? Second item, Solr and Spark. You already know Solr, probably most of you already know Spark as well. Bring these things two together. Solr is that real-time query engine, right? Tell me what I need to know about my data right now. Spark is that crank in the background that says, let me make my data smarter, right? Let me go build a machine learning model off of all of these signals such that I can then overlay it on top of my search results, right? Obviously an open core platform here. And then last but not least, we see you all, like Trace said this morning, building the same things over and over again, connectors and security and UIs for managing rules and reports and dashboards, etc. So that's Fusion in a nutshell. Architecturally speaking, the right-hand side, there's your open core pieces. If you're not familiar with Zookeeper, I just summarize it as Zookeeper is what gives your DevOps people their nights and weekends back. Moving to the left, the core services. These are all the value-add pieces that I was just talking about, connectors, APIs, UI, etc. In many ways, when I think about Fusion, I often get asked the question, well, what do you put back into open source? What do you put in Fusion? For us, like everything that helps us answer questions or scale our ability to answer questions all goes back into Solr. And then we often in the core services layer and up above, it's all about either asking smarter questions of Solr because perhaps you don't have a data science team and we do, or perhaps you're not sure about building recommenders, things like that, or we just take care of a lot of the plumbing and infrastructure side of it. So that's Fusion in a nutshell. You can download it and try it out. Digging into the next level around, if you go look at this code in SearchHub, just real quickly, a few things to highlight here. You can go download and try out Lucidworks View right now if you want. What we did is basically take that default view experience and then we added a bunch of configuration. We added some configuration as well as some additional, if you speak Angular directives. We then also integrated the Snowplow Tracker. If you're not familiar with that, it's essentially kind of like if you're familiar with like Google Analytics, you put a little cookie tracker JavaScript thing onto your site, and all of a sudden you have this whole wealth of information about what users are doing on with your content. Snowplow is an open source version of that Google Analytics cookie tracker. You can go try it out yourself if you want. And then we have got a little pretty lightweight middle tier built on Python Flask that does things like bootstrap the whole system with config, so it's very repeatable. You push like one button and now you have this running and indexing and all of that kind of stuff. It's where we build things like our schedules and pipelines and all of that kind of stuff. And I'll show you a little bit of this later on. Why Python Flask? My team, we know Python, and Flask is nice and easy. So you could argue till the cows come home about what web application layer you should put it in. Frankly, this was the easiest and most expedient. So going a little bit deeper, I mentioned we have a number of different data sources. The email makes up the bulk of the content, although I expect the Stack Overflow stuff, which we just added maybe a couple of weeks ago, will start to challenge the mail archives as we expand out the number of tags in Stack that we're crawling. Right now, so we're doing all the email archives of those Apache projects. We're also doing Stack Overflow for I think 4 or 5 different tags, you know, where things are labeled like this is a Solar question, this is a Spark question, etc. As well as GitHub, the code repositories for things like Solar, etc., or at least the mirrors of those repositories. If you're familiar with Fusion, underneath the hood, we have what are called pipelines that both operate at indexing time and query time. They're kind of that layer that sit in front of the indexing engine. And the nice thing about them is you don't have to bounce Solar or change. You can just say, I want to update this pipeline, and it'll push it out across your cluster. It's essentially an ETL tool where you can say, oh, I want these Solar parameters for my query. I want these fields added to my document, these fields taken away. I want to call out to a third-party natural language processing service, or in some cases for the email, we have a custom stage that we dropped in there that handles more smartly parsing mbox files, which is what the email content is in to begin with. At this level, of anybody who's actually built these kinds of systems, you know that crawling is one of the hardest problems out there. I'm really proud of what we've built as a web crawler. It has or as a crawler in general. It has a lot of capabilities underneath the hood. Over on the right here is an example of kind of some of the crawling of Stack Overflow, and then underneath the hood, just a small example of all the work I started to do using our JSoup integration, which allows us to go in and very minutely say, I want this particular piece of data off of this particular page, and I want to add that to this field on my document. This is useful not only for this kind of application where I just wanted to get off the Stack Overflow, I wanted to get rid of all the boilerplate, just get the question, get the proposed answers, and get the accepted answers. And so that configuration basically shows you how to go get all of that just out of Stack. Is it 100% perfect? I haven't tested every last bit, but I think it's probably at like the 95, 99% level there for doing it. If you haven't tried JSoup, it's awesome for this kind of stuff. Of course, it's also, there's a challenge with it in that if Stack goes and changes their tags and all of that, now all of a sudden you have a system that's going to be broken. And so there's ways we can deal with that as well. But these are the challenges of crawling web content, obviously. Other challenges kind of on the data acquisition side, I'm an Apache member. And I kept getting banned by the ASF, and I'm like, guys, I work here. Why can't you let me in? And yet they're like, nope, stop doing that. So we had to figure out some workarounds around their fail to ban. That's primarily what that mirroring of all of the mail has to do with. And then last but not least, probably on the data acquisition, what's a really interesting challenge there, especially in email, if anybody's ever dealt with parsing email, you know, things like thread hijacking and getting threads to all relate, you know, the proper threading of messages, all of that. It's not a solved problem, and it's not all that easy. You can get most of it right away, but then that kind of last mile to make sure you have proper threading, is a challenge. And so here on the mail threads data acquisition, there's some Spark jobs that will actually offline compute the mail threads for the overall collection. And then there's also a real-time indexing component. As new mail comes in, it'll say, hey, do I know this thread already, and associate it. So you see a great example of that offline compute to make things smarter, and then the real-time lookup and leveraging of the best known state of this data, right? So that's a great example of that on the indexing side of the equation. Deployment-wise, pretty straightforward kind of stuff. We deploy on Amazon. The Fusion stuff kind of runs on bare Amazon. And then the client and front end, we actually put in a Docker container, because that way we can just, if we want to add more, we can add more Docker containers. All of the code for spinning up those Docker containers is all built in as well. There's a couple of scripts. You just say Docker, I think it's just docker.sh, and it'll give you a Docker instance. There's a little bit that you have to do there around making sure your IP addresses are set and all that. A little bit of config in there, but that's all in the README. Nothing too fancy here. This isn't a, this isn't a million events a second kind of site or anything like that, right? But the nice thing here is all of this stuff is repeatable by you. Especially you go get Docker on your own machine, and you can have this up and running pretty quickly with real data coming in. So that's the deployment side of things. Getting in then to the more interesting pieces. I promised puppies, there's your puppies. Signals, like I mentioned, I've kind of talked about signals at a high level here. I kind of think about signals as this abstract notion of any event that happens in your system that you find that might tell you what users or downstream systems care or think about your content, right? So any individual signal is not all that interesting, unless maybe it's from your boss. It's that your boss is clicking on your site, or the President of the United States is clicking on your site. Those are interesting signals by themselves. But for the most of us, for all of us average Joes and Janes, the signals are pretty boring by themselves. But of course, if you've been up on machine learning and on collective intelligence, you know those signals are important at a broader level. And so if you go in and look at the UI code, this is probably one of the main customizations we made to Vue, was to integrate the Snowplow Tracker in. Vue out of the box contains a very lightweight signal example of basically clicks. Snowplow gives us access to a whole bunch of other types of interactions, as well as just automatically starts sending you things like user agent and time on page and all of these other kinds of things. And so you can read them here, but there's a number of interesting things that we do. We capture a number of pieces of information about the user. It's all anonymous, of course, but things like cookie IDs, session IDs. We actually also calculate unique query IDs. So you might imagine a user actually asks the same question multiple times in a session. That can be important to distinguish between the two. So every time a user submits a question, there is essentially a UUID attached to that query that gets sent in by Snowplow to our signals index. Other things, actually we don't do IP address anymore because we're not using HTTPS, and Google and the others have decided you should only do location. That was an opt-in option, but I removed it recently. Snowplow does provide it out of the box. And then we also send timing data, how long did it take for the page to load, all of those kinds of things. Not really doing anything with that yet, but we probably will eventually. So that's kind of the metadata around a signal that comes in. Yep. Yeah. Yeah. We'll show you. This site is relatively recently new, so there's not a lot of signals in there yet, but we can talk about how it's leveraged, and what our plans are there. Some of the actions that we track, I'll show you a little bit. The cool thing about putting this all back into Solar underneath the hood in Fusion is I can facet on it, and I can search on it, and all of those good things, right? We do things like what pages are you on, how long are you on those pages. That's actually configurable, but I think we do 30 seconds right now. Search with query. And we also, whenever we capture that search with a query, we're also capturing what documents did you see as well as what facets did you see, because when you start to think about tuning relevancy off of signals, it's often useful to not only look at what did the user actually choose, but what were their other choices. And so you can start to compare those things. Then when they actually do click, you get things like query, the query that they did, the doc ID that they chose, the score, the position, whatever other metadata about that actual click. And then we do the same thing for type-ahead search as well, right? So if you think about it, type-ahead search is yet another search, to quote, if you saw Eric Hatcher's talk this morning. And so all of that stuff is captured as well. How many characters did you type? Which suggestions did you get? Which ones did you choose? Which ones didn't you choose? Et cetera. All of that stuff is in the UI, and you can go look at the code. At the end of the day, it's sending us documents back to Solr that are of certain types. Going from there then, and this is where I'm gonna cover it at a high level, and then we're actually gonna go look at some code and perhaps even some results of it. Underneath the hood then, when you start to think about doing machine learning, one of the reasons why we built Fusion this way with that kind of Spark Solr is that Spark comes with a whole bunch of machine learning capabilities out of the box that are designed to scale. So things ranging from very simple k-means clustering, logistic regression, up through LDA, random forest, word to vec, so on and so forth. And so if you start to think about this notion again of Solr is my real-time view of the data, Spark is where I go learn more about the data and then enhance my understanding of it, you then need these kinds of capabilities. We have some really simple examples laid out in a file in the GitHub repository called Spark Shell Helpers. It's in Scala, and you can go check that out. We'll actually look at it here in a minute, okay? Last but not least, before I get to the demo, one of the other things that comes with Fusion is what we call our experiment management and Bandits capability. This is still, frankly, early. We're primarily only exposing it through APIs. It's in beta. But it does allow some really interesting things. If you've heard me talk before, I think one of my common themes is I want to get, especially in the e-commerce consumer space, get people out of the mindset that they're going to go write 10,000 rules to manage their search site. And instead, start to think about how do I build up experiments that test my hypotheses around what might work in an application, right? I wish this was my brilliant idea, but it is not. Like if you look at any of the big internet search environments, by most accounts, 5–10% or less of people ever see what is the official version of that search engine. Everybody else is in an experiment. I don't know, don't quote me on the exact numbers there, but I'm sure there's other people in the room here who have experience with that, where, essentially an experiment can be anything from I'm changing the color of my logo to I'm fundamentally changing my ranking algorithms. And so I want to test that with real users on live data and all of those kinds of things. So you've probably heard A/B testing, multivariate testing. This is kind of what we're getting at. One of the things we've done then in Fusion is if you think about all of that data, well, what is it? All of that feedback that tells you what users care about in your system, that's signals, right? So you've got all this signal data. Why don't I then leverage that again, dog food, the fact that I can go calculate how my relevance is working, I can run experiments, et cetera, off of all of that data, right? This allows you to, I think, help you get into that mindset of experimentation away from hard-coded rules, or at least the minimization of those rules. I don't think rules ever go away, but you want to make sure that they're minimized, you want to make sure they're version controlled, you want to make sure they have a lifetime, right? I can't tell you the number of places I've built rule systems before where, I'm looking through the stack of all the rules, it's 5 years later, and it's like, who wrote that rule? Oh, Jane did. Well, who's Jane? I've never met Jane. Oh, she quit like 6 years ago, or 4 years ago. And it's like, why is that still a rule? Oh, well, I don't know, it's in there and it works. I mean, that's not how you manage these things, right? You need to have lifetimes around them. And so one of our goals with all of this stuff is really to drive down the cost of experimentation. Again, if you look at that best in class around search, people are running experiments all the time, whereas if you look at the next tier down or 2 tiers down, they maybe run 2 or 3 experiments a year, and experiments are super costly, right? We better get buy-in from the entire company in order to run this experiment, whereas like sometimes somebody just has a really good idea. Can't I just go try it out on 5% of my traffic and then let the numbers speak for themselves? That's what we're trying to get at here. And then once we have those experiments, then you can start to get in this mindset of these bandit approaches where you can say, I'm helping my business both explore and exploit my content, right? Exploration is all about making sure that new stuff gets a chance. Exploitation is all about, let me go make my money right now because I know this is working right now, right? Like, you probably wouldn't do exploration on Black Friday of the Christmas holiday season, but you might do it in February, right? Black Friday is all about exploitation, sorry to say, for all those who aren't in e-commerce, but let me get as much money from you as I can right now. So all of this stuff is in Fusion 3.0. It's still early stage. We're getting docs out very soon. I've got some examples in there. But you can do things like record and calculate relevancy metrics, things like mean reciprocal rank, precision recall, NDCG, all of that stuff built in. Of course, that ties back into the dashboards and being able to report on this stuff over time. And then it also has support for bandits. If you're not familiar with what multi-arm bandits are, this book is a good getting started book. It's a quick read, it's an easy read, you'll get it almost immediately. But the idea basically is you tell the bandits, here's my 5 or 6 or 10 variations of what I want to experiment on, and you let it loose on the site. And then as users interact with it, you're basically sending a reward back into the system saying, hey, this user liked this variant. And so then over time, the bandit algorithms will automatically select the variants that are performing best while still giving the other ones a chance to perform in the future, right? So you can kind of think about it, maybe one variant is having a bad day, right? And so maybe tomorrow that variant is going to perform better, so the bandit will automatically manage those experiments. Again, tying that back down into how do I drive down the cost of experimentation. So I know I'm running out of time here. Let's look a little bit at some of this in place. So one of the first things, this bandit stuff, there's a definition in the code. One of the things we have is a very stupid, simple experiment. This little ad up here, if you hit refresh a bunch of times, you're actually going to see 2 different ads going on. It's just a simple example of a bandit where if you were to click on that, you'll actually send a reward back to the system, which will then update the bandit saying, hey, this user clicked on this thing. And if you clicked on the other one, which I think the one is like a learn more banner and the other is a download banner for Fusion. So now that you all know that, you can go bias our results. But we're not doing this for the purpose of actually doing a real statistical analysis. It's the purpose of showcasing how you do it, right? So that's one example of the bandits. You can look at the definition underneath the hood. I think I've got it up here in IntelliJ. That might be a little hard to read. Let me zoom in if I can. But you can see this is actually a very simple bandit. There's just 2 images and 2 pieces of data with it, and then I chose a certain bandit approach. Again, don't even bother trying to read it. Go look in GitHub, and you'll see it there. Beyond that, then, I promised some on the machine learning. Again, this is kind of, let me see if I can zoom in here. This is some example of a number of different things. First off, it's an example of our Spark Solar integration, which Tim and his team have been working on a lot. That Spark Solar integration does a lot of really cool things, takes advantage of essentially knowing when is it better to calculate something in Spark and when is it better to calculate something in Solar, and it knows how to push things down in the right places, or at least for the most part. I know there's always improvements to be made there. Tim's laughing because he knows. But as an example, kind of I'll walk you through this a little bit here and then just show you some output. this very first thing probably looks pretty familiar to people who have done solar before. That's basically telling Spark how to connect to solar. You can see I'm connecting to this Lucid Find, and I'm running a query. This one happens to be our favorite ** query. And then I want these fields. You can do other things, basically any parameters that you can feed to a solar query, you can put in this in your request. And then for those who are familiar with Spark, basically SQL context.read.format solar, I now have a data frame. And now I can do any data frame operation I want on it. Scroll down here a little bit more. One of the cool things Steve Rowe, who works for us, did, and Tim and team did, is all of the Lucene analyzers are now available to you in Spark. So all of that language handling, etc. Spark has a very limited view of text, right? Because most people don't like text, right? Because it's hard. We all love text, otherwise we wouldn't be here. All of those analyzers that you're so used to in Lucene Solar are all available to you. So I've got my solar data. I'm now vectorizing it so that I can do some machine learning things. And then I scroll down here a little bit. Sorry for the touchiness there. 3 lines of code, k-means clustering. K-means is like the punching bag of clustering, but it's a great starting point. So if you've never done clustering before, go run these 3 lines of code against this data set. You'll have clusters built on top of all of those emails that you've indexed. Okay? Pretty cool. The other really cool thing then is this next line. And I'm not actually going to run that here. It does update your index. But what this does is I build my k-means model, and then if you know anything about it, basically you get these labels for the cluster centroids. And then the question always is, well, what documents belong to what cluster, right? In Spark by itself, that's kind of a shit show, for lack of a better word, right? But in Search, we know how to do this, right? So all we do is we attach those cluster centroids back to all the documents that they belong to, and then write it back to Solar. That's really cool, right? Because now I can go into Solar and say, add a facet on centroid. And now I can just click my facets. Oh, this cluster has these documents. Let me go look at them in my typical search interface. That's awesome. I can't tell you the number of data scientists who don't do this basic machine learning search loop back and forth. Instead, they're dealing with really complex ways of dumping out text files and all of that kind of stuff. This is so much easier. On down the chain, we've got a few examples of doing some analytics on those centroids. Next up, around line 66. For those familiar with topic detection, or LDA, 3 lines of code. Obviously, there's some more underneath the hood in this build LDA model thing. But again, taking those same vectors and get back topics. If you're familiar with Word2Vec, same kind of thing here. 2 lines of code to do Word2Vec. And again, you can actually update your content back. One of the things we're about to deploy in SearchHub is build a Word2Vec model offline of synonyms and related terms. At indexing then, as the content comes through, go look up additional terms from the Word2Vec model, add them onto the documents, and then now you can facet on things like related terms. That should be in production in the next month or so. Last but not least, there's a random forest example in here. If anybody's done 20 news groups as a classification problem, basically the idea is, can you predict that this email belongs to this news group? That's what that does, but across all 37 or 100 projects in there, it's kind of 20 news groups on steroids, as I like to call it, using best-in-class classification. So if you want, this is an example of how some of this stuff looks. There are some clusters. They're not all that pretty just yet, but they are. There's 20 different clusters for k-means there. Down a little bit further, you can run all this yourself. There is an example of some of the topics that were detected. Let me try to zoom in here. It's not working very well. And then last but not least, I just did a Word2Vec model on, or I think I did. Where did it go? Maybe I didn't run that last one. Sorry, I didn't run the last Word2Vec one, but basically when you run that, you get a list of synonyms and related content around that. So that's that, and I'm getting the wrap it up sign, so that's my demo, another cute puppy. If you want to learn more, our lead data engineer, Jake Mannix, is going to cover the recommenders part of what's going on in SearchHub and show you how to build some multimodal recommenders. All of the code is available for you there, including I've been starting on an actual bot that will use SearchHub to answer questions as part of Slack. And that's how you can get a hold of me. I think we got time for maybe 1 or 2 questions. I know that's a lot to take in, so. Any questions? Yep. Is it possible to do multiple A/B testing at the same time? Yeah, I mean, as I understand it, you can set up and run many different experiments and have, depending on who, you can basically use the pipelines then to choose which experiments you want to run, things like that. Yeah. The SearchHub itself have an API. Yeah, no, I'm just hitting a query pipeline endpoint with the Slack bot. That's all that's doing. Yeah, it's just hitting our query pipeline. Yep. Yeah, that's publicly available. I mean, it's essentially a solar pipeline API. Yep.
You know your feedback loop where you would actually use Spark to find some data and you were feeding it back into the index for next time round?
Yep.
You write it again. What kind of, if you were to scale that up, what kind of impact would that be?
So the question is that feedback loop where we do stuff in Spark and then write back, and what's the impact? I mean, basically it's going to depend on how many nodes of Spark you have and how many nodes of Solar, but as I understand it, it blasts it in. We've got customers who use Spark to index, and they build huge indexes just by blasting from Spark at very large scales, and it's all about Solar and Spark scalability. So yeah, I mean, you can crush it if you want. You probably don't want to, but yeah, the capability's there. I think we've got some, I mean, we're talking hundreds of thousands of writes and per second and things like that. Yeah. Yeah, I mean, you can. Yeah. Yeah.
Do you use doc values to kind of make the updates very, very small, or are you rewriting the whole document?
I think it kind of depends on what you're updating, but because not everything's doc value. The Spark Solar integration is schema aware at the data frame level. RDDs are obviously raw underneath, but yeah, it tries to be smart about all that stuff. I don't know if that's 100% optimized yet, but ask Tim, he's right over there. Thank you very much.